Hello student, now we are going to discuss about geography paper second, that is GG 102 physical geography atmosphere. Now we have to study about structure of atmosphere. On the basis of temperature and zones of temperature changes, the homosphere is divided into different layers. Then heterosphere. Heterosphere lies above an elevation of 90 kilometers from the Earth's surface. It is made up of four gaseous layers. Among all the gases, heavier gases tend to predominate in the lower areas, while lighter gases are found at higher elevation. Among the gases, nitrogen layer, it is lowermost layer. It begins from 90 kilometers. It is made up mainly of molecules of nitrogen. Then ozone layer in heterosphere. It extends from 200 kilometers. It is made up of molecules of oxygen. Then helium layer. It extends from about 1100 kilometers. It is composed of atoms of helium. Then the hydrogen layer. It is outermost layer of the atmosphere and composed of atoms of hydrogen. It is about the heterosphere. Then homosphere is a zone which lies up to the height of about 80 kilometers from the surface of the Earth, where the chemical composition of gases remain uniform. Then layers of atmosphere. First one is troposphere. The troposphere is a lowermost layer of atmosphere. Troposphere literally means the region of mixing. The average height of this lowermost layer of atmosphere is about 11 kilometers above sea level. However, its height varies from place to place and season to season. Under normal condition, the height of troposphere at equator is 18 kilometers. Towards both the pole regions, it is only 6.4 kilometers. At 45-degree latitude, it is 9.6 kilometers from the Earth's surface. The altitude of troposphere is also associated with seasonal changes. In this zone, temperature decreases with increasing elevation, with the rate of 6.4 degrees centigrade per kilometer or 1 degree centigrade per 160 meters until minimum of about minus 50 degree centigrade or minus 60 degree centigrade are reached. In this layer, temperature of air decreases with increasing elevation with the mean rate of 1 degree centigrade per 160 meter. This rate of decrease in temperature is known as lapse rate. In this layer, atmosphere gets heated and cooled by the process of conduction, convection, and radiation. Atmospheric phenomenon like fog, frost, lightning, thunder, clouds, precipitation, etc. are found within this layer. Then another layer of atmosphere is tropopause. Tropopause lies above troposphere. Relatively, it is a thin layer of atmosphere. The thickness of this layer is about 3.2 kilometer. This layer is known as ceiling of troposphere. In this zone, temperature of air remains constant. Then the another layer of atmosphere is stratosphere. This layer lies above the tropopause and extends up to 50 km from the Earth's surface. The temperature remains constant at somewhat extent, but at the height of a 32 km temperature of air increases gradually with the increase in elevation until the temperature of 0 degree is reached at about 50 km. In this zone, much of atmospheric ozone is found. This the lower portion of the stratosphere is having a maximum concentration of ozone. Is called as Ozonosphere. Though the limit of Ozonosphere is fixed up to about 58 kilometer, it is ranging between the height of 15 kilometer to 35 kilometer from sea level. Ozone absorbs ultraviolet rays of the sun and thus protects the earth from intense heat. Then, above the stratosphere, there is a layer, is a tropopause. It lies above stratosphere. It is a thin layer of the atmosphere. From the stratopause, the temperature of air begins to decrease with increasing elevation. Another layer of atmosphere is a mesosphere. This layer of atmosphere lies between 50 kilometers and 80 kilometers from the surface of the earth. The temperature of air decreases with increasing elevation. In upper part of the mesosphere, oxygen exists in its atomic form. Then the another layer of atmosphere is mesopause. It lies above mesosphere. It is thin layer. Temperature of air begins to increase with increasing altitude. Then the layer of atmosphere is the thermosphere. The part of atmosphere beyond mesopause is known as thermosphere. Temperature increases rapidly in this layer with increasing height. It is estimated that the temperature at its upper limit is very high. It may be pointed out that this temperature that this temperature cannot be measured ordinary measured by ordinary thermometer because the gases become very light due to low density of gas molecules are too sparse to transfer quantities of energy to ordinary thermometer. Thermosphere is divided into two layers, ionosphere, exosphere. Ionosphere, this layer extends from 80 kilometers. The distinctive feature of ionosphere are the highly energetic gamma and X-rays. The insulation is absorbed by molecules and atoms of nitrogen and oxygen. Long wave radio waves are reflected back to the earth from the lower part of Ionosphere. This layer is called as canally heaviside layer. There are number of ionic layers in this sphere. For example, D layer, E layer, F layer, G layer. D layer reflects the signals of low frequency radio waves but absorbs the signals of medium and high frequency waves. This layer disappears with the sunset. It is associated with solar radiation. E layer, also known as canally heaviside layer. This layer extends between the height of about 104 km to 110 km from the Earth's surface. It reflects medium and high frequency radio waves back to the Earth. This layer is produced due to interaction of solar ultraviolet photons with nitrogen and nitrogen molecules and thus does exist at night. Sporadic E layer. It reflects very high frequency radio waves. E layer is generally found at the height of about 150 km. It is produced due to reaction of ultraviolet solar photons with oxygen molecules and thus disappears during night. F layer consists of two sub-layers, that is F1 and F2 layers, and are collectively called Appleton layer. These layers reflect medium and high frequency radio waves back to the Earth. G layer is most probable probably present day and night, but it is not detectable. Then the exosphere. The outermost layer of the atmosphere is known as exosphere. It extends beyond the height of about 640 kilometers from the sea level. At such a great height, the density of atoms in the atmosphere is extremely low. The temperature becomes very high at its outer limits. Next part will be next unit will be continued during the next prayer. Thank you.